Hey folks, Paul Abernathy here. In this video, we're going to talk portable generators. We're going to talk about the difference between a floating generator and a bonded generator, and when you might use one for supplying power to a dwelling, okay? And then when you'd use one for like just portable use, job sites, camping, and things like that. And when you would need one that's considered a floating neutral, maybe, or one that's a bonded neutral. Well, what's the difference? So we're going to be looking at that today in this episode. Again, all of this is out of our grounding and bonding program, and you can go find more information about that here at the Fast Track System. But we're going to talk about again today portable generators, and we're going to be working out of the 2023 edition of the National Electrical Code. So all of our references are going to be out of the 2023 moving forward in this episode. So keep that in mind if you're happen to be watching the video and you're wondering maybe something doesn't align with your 2020 or 2017 edition as far as the code references. We're working out of the 2023. Okay. All right, so we're going to be looking at 250.34 portable. Now we're going to be looking at the vehicle mounted or trailer mounted generators in this episode. We're just going to be focusing on portable generators. And there's a lot of stuff that's quite confusing about generators that we've learned over the last couple cycles. Is that, when would you want one that is the frame of the generator bonded to the neutral point? And when would you want to have, or when could you have a floating neutral type generators? So we're going to be looking at those and trying to break it down to maybe simplify it a little bit for those that are looking to buy a generator, or maybe you have a generator and you're using for a current application and you really don't know if it's safe to be using it, what you're using it for, and maybe you just never run into an issue where you tested the safety of the design because it's never come up, those type of things. So we'll kind of look at that. We'll read along because, again, it's so important for us in this program to follow the written content and then elaborate on that written content. That keeps us on track with the material. So we'll be looking in at 250.34a portable generators. Now, let's look at the requirement. It says the frame of a portable generator is not required to be connected to a grounding electrode as defined in 250.52 for a system supplied by a generator under both, important to highlight that, both of the following conditions. So what this is basically saying is, okay, I have a portable generator and I do not have to drive ground rods or establish a grounding electrode system for this portable generator if the following conditions apply. And there's two of them, and you have to comply with both of these conditions. Or the generator has to comply with both of these conditions. Okay, so here they are. The first one is the generator supplies only equipment mounted on the generator, cord and plug connected equipment through receptacles mounted on the generator, or both. All right, so what's important to this one, to me, is the or both. So if I have a portable generator that's got receptacles built into the generator, which is typical of a portable generator, then I do not have to have a grounding electrode system for this generator. Okay, now that's the first part. The receptacles are mounted on it. Okay, next, if I had a generator that was specific to a piece of equipment and that equipment is actually mounted on the generator, then again, I would not have to establish a grounding electrode for that generator. Okay, so assuming you meet that first condition, then no electrodes are required for your portable generator. Next condition right here, it says the normally non-current carrying metal parts of the equipment and the equipment grounding terminals of the receptacle terminals are connected to the generator's frame. Okay, all of that's extremely important. So this says that the metal frame of the generator has to be connected together with, if there are receptacles on this generator, then it would have to make a connection from the frame over to the terminals, right? For the equipment grounding terminals on the receptacles, all connected together. And ultimately, it's going to connect back to the grounded point or the neutral point on the actual generator. Okay, so this is what we refer to as a bonded generator. Okay, it makes all the connections, but don't worry, we'll look at a graphic that'll kind of make it all make sense for as far as generators go. But before that, we got to have a little bit of a discussion. And here's our discussion. And oh, by the way, this is indicative of how our course goes. We're not just going to give you a code reference. We're going to also gotta kind of give you the code, but then we're going to kind of go into a description. So anything that can make the NEC easier to understand is important. And that's what these courses all do in our Fast Tracks program. It tries to make things as easy to understand as possible. You're still going to obviously have questions, but the effort is to try to make things as easy to understand as possible and support it with illustrations where necessary to kind of ease that understanding. So let's look at it here. So as illustrated in figure 2-70, which is down here, we'll see in a minute, it says the system neutral and the equipment grounding conductor of a portable generator are required to be bonded to the frame of the generator. It's kind of what it said up here in item number 2. Okay, now, without the connection between the neutral and the equipment grounding conductor, a path does not exist for current from a line to ground fault to return to the source. Remember, it's trying to get back to where it originates, okay? Never trying to get to Earth. So if it originates at the generator, the windings, it goes out, serves the load, everything comes back. It's all trying to get back to the source, okay? All right, so if you don't have that connection from the frame over to the neutral point and something gets energized in some metal parts of the piece of equipment that's plugged in to the generator, or something happens on the frame, if it can't get back to the source, then it's not going to be able to clear an overcurrent protection device. Okay? So that could be very much problematic, right? So keep in mind that all equipment must comply with 250.4a by providing an effective ground fault current path. Now, we're all pretty familiar with that in the code. We're required when we take out branch circuits and we make all of our connections and we do everything, we use proper terminations in accordance with 250.8, then what happens is we're establishing an effective ground fault current path. Well, there's no different here on this generator. So we have our receptacles with our equipment ground terminals. Okay, it's connected to the frame. The frame is connected to the neutral point on this generator so that we can complete that cycle and allow the overcurrent device to function and to allow the GFCIs to function that are typically built in to these portable generator setups. Okay. All right, so let's look at this real quick. So here's a generator, very standard generator. This is a 5,000 watt generator. You notice here's the metal frame. Okay. You notice it's on non-metallic wheels, plastic wheels, so it is not contacted with the earth. Okay. Now, this frame is not required to be connected to an electrode under the specific conditions that we just read. Okay. Now, obviously, here are the receptacles that are built into the generator. That meets one of the components. The other aspect of this to not have to have the electrodes is that it has to have the connection from the neutral point and from the equipment grounding terminal connections here on these receptacles over to the frame. Okay. All of that has to take place. All right. What does that look like in an illustration? All right. So here's that generator right here. So this is the generator above drawn out in an illustration. So here's phase A, here's phase B for the 240 volts. Here's the neutral. So phase A to the neutral 120, phase B to neutral 120. All right. So here's all of our setup. Here is your connection right here that creates this bonded generator over to the frame. So the equipment grounds are connected to the neutral point. Everything in this frame is connected to the neutral point, all meeting the requirements that we just saw. No electrodes are required for this portable generator. Make sense so far? Okay. Now, remember, we're looking at the 2023 edition of the National Electrical Code. And why is that important? Because there was basically a change in terminologies and in technical jargon and how we explain something. And let me read it to you and you'll get a better understanding, especially if you're in a 2020 or 2017 edition and you see us doing this 2023, you're thinking, okay, isn't that metal frame acting as an electrode and that's why we don't have to have an electrode? No, it's not, because that frame is not connected to Earth, so it is not an electrode, right? So let me read it here. It says the NEC no longer refers to the frame of a generator as serving as the grounding electrode for the system produced by the generator. It can't be, because the whole premise here was it doesn't have electrodes. It's not connected to Earth. It says, this section previously stated that the frame of a portable generator was not required to be grounded and was permitted to serve as the grounding electrode for the system supplied by the generator. That is not technically correct, because it's just the metal frame that has to be bonded to the neutral point. Okay, so again, this is a statement that might have been used in the past, but it's been clarified. So it says the present language is a technical correction to the code because the frame of a generator is not grounded unless an earth connection is made through one or more electrodes, grounding electrodes. And we just saw that they're not required on specific portable generators that meet the conditions. Now, it also goes on to say grounding type receptacles and ground fault circuit interrupter receptacles are typically installed on portable generators for supply of equipment through flexible cords. Okay, so we kind of saw that here in this illustration. Here are the receptacles. Everybody's seen it. You go buy your portable generator, whether you use it for a job site, construction site, campsite, however you want to do it, that's your portable generator. Okay. Let's dig a little deeper here. And I've got an important area highlighted here for you, but let's see here. Portable generators. Now, there are two different types of portable generators that you're going to run into. You're going to get some that are the bonded neutral, like what we just saw, okay? And then you're going to get a floating neutral. Now, if you think of the bonded neutral, the one we just talked about, then that's going to meet the rules, and that's going to allow the overcurrent devices on the generator to trip. That's going to allow the GFCIs to function properly. Whereas on a floating neutral, that just can't happen. Okay. Now, that doesn't mean that you're not going to overload and trip an overcurrent device, but it's just, I'm going to show you how it really can happen when it comes to the floating neutral. Now, that doesn't mean that it's not going to work and you're not going to plug an extension cord into it and you're not going to get power. Obviously, you are. But when you need those devices to function safely and clear a fault, then that's when the problem occurs. And you might say to yourself, well, I've never tripped a breaker on my floating neutral generator. There's probably a reason why that hasn't happened, okay? Now, portable generators with a floating or bonded neutral. Portable generators are available that do not have the neutral connected to the frame. They're available out there. These generators are often referred to as a floating neutral generator. Since there is no path for ground fault current to return to the windings, get back to the source because it doesn't have that jumper, okay? Then line to ground faults, such as from a faulty tool or appliance, will not be cleared. They will not function the overcurrent protected device properly. Okay, so it creates an unsafe condition. So if you're using tools, they get, if you're still using corded tools on job sites, then again, it can create an unsafe condition if you're using a floating neutral type generator. Okay. All right. Also, now we get to the green part. Let me get rid of this to get rid of that here. Also, a GFCI device that is intended to protect people from electric shock hazard cannot function. Thus, these generators should not be used as standalone operation. So, floating generators that do not have a bonded neutral to the frame, you do not want to use on a job site, construction site, maybe for your camper or something like. You don't want to use them in those applications. Okay, if you're relying on that overcurrent device on that generator, if you're relying on that GFCI device to function properly, you do not want to use a floating neutral generator. You want a bonded neutral generator. Let's meet a little more here. It says you should be aware that generators of this wiring arrangement, that is the one that's the floating neutral, by the way, do not comply with the requirements of 250.24c that the neutral conductor be bonded to the frame. Okay? So again, first of all, trying to meet NEC rules, and this is going to become even more important if you happen to try to use one of these generators to supply like a dwelling or something like that, then it becomes pretty critical that it can't comply with 250.24c if it's a floating neutral because you don't have that neutral to the frame connection. Okay, that's a problem, right? All right, next, is there a safety standard for these generators? Yes. So that safety standard comes from the Portable Generator Manufacturers Association. That's this right here. And they are ANSI PGMA G300, and the latest edition, I guess, was the 2018. It hasn't been updated since then, since this is 2023 information. And they're going to give you the standard. Now, in that standard, it's going to give you various details of the construction of a generator. And it's also going to tell you the instructions on bonding the neutral to the frame if the generator has 15 or 20 amp 125 volt receptacles. Then it's going to say, hey, if you've got these receptacles, guess what? I'm going to need you to bond the neutral to the frame of this generator. Okay, so that's where you're going to get all those instructions. Now, when it comes to generators, the only other thing I can tell you is you have to be careful because there's a lot of makes of generators. And not all generator manufacturers understand the difference and the importance of what they're selling their generator for. Most of the portable generators that you would see out there, you'd have to think they're being used in a portable application as a standalone, as a separately derived type system, right? And so if that's the case, we want to make sure we have that system bonding jumping in there or that connection from the neutral point over to the frame. Okay? We want to make sure that takes place in those type of systems. But you got to be careful what you buy, okay? So you know what you're getting. And I would also say for homeowners, the people that want to buy just a portable generator to try to do backup power for their house, be very careful because a generator with a bonded neutral is a separately derived system, right? And so when you have that connection and you get, let's say, a transfer switch and you don't pay attention and you get one that has that bonding in it like that, then you don't get a transfer switch that switches the neutral, then you're going to get parallel paths of neutral current traveling, and that is an unsafe condition, okay? Because basically you have to understand that what you're dealing with is parallel paths of neutral current. So it can be really unsafe. But we'll look at all that in an example and kind of show you what can happen. But don't worry, we'll dig into that in a minute. All right. Next, portable generators with the floating neutral should only be used if connected to a premise wiring system through transfer equipment. Okay, so if you have a generator and is a floating neutral type generator, then you should make that application through a transfer switch. Okay. Now, because if it is floating neutral, by the way, then you've got the separation, right? You don't have any jumper between the neutral and the frame. Okay. That type of scenario. So it's technically not a separately derived system at that point. Okay. All right, so let's look at what we're dealing with here. Okay, so line to ground fault currents can travel over the equipment grounding conductor to the service equipment and then back to the generator through the neutral conductor. Obviously, for this type of generator, the neutral should not be switched in the transfer switch equipment and should be located very close to the service to keep the impedance of the completed fault circuit to a low value. Okay, so all proximity taken into consideration of where you put this equipment. One of the biggest things that I always run into with people is when they do a generator for their house and they determine whether or not, depending on what happens in the transfer equipment, right? If the transfer equipment switches the neutral on it, okay, just breaks the neutral, then what you have is a separately derived system. Okay. Now, if it doesn't switch to neutral, then it's not a separately derived system. Okay. So it's important when you're selecting the equipment to know what you're doing. But don't worry, we're going to dig even deeper. We're going to look at this. Okay. Now, only portable generators, and again, we said this, so redundancy here, only portable generators that have a neutral bond to the frame should be used in a standalone functions such as temporary power to construction sites, picnics, concerts, and so forth. Okay. So if you're buying generators for any of these applications, they're temporary power, construction site, pull it up, run the job site, you want to make sure that you have one that has the neutral bonded to the frame. So you want a bonded generator, okay? If you take anything away from this, that's what you want. Why? Well, because that's going to allow the overcurrent devices to function properly, and that's going to allow the GFCI devices to function properly on the generator itself. Now, also as defined, the definition of ground fault circuit interrupter in Article 100 is for portable generators, the frame is permitted to function as earth or ground for the generator. Okay? GFCI devices will function as intended only on portable generators that have the neutral bonded to the frame. Right? Can't make that even as clear as we can make it. Okay? GFCI protection cannot function on generators that have a floating neutral. Again, not sure how clear we can make that to folks. Okay? Why? Because there isn't a return path for the ground fault or stray current to return to the windings, back to the source of the generator. It's basically just going to stop on the frame. And that means that it could stay energized. It's not going to clear anything. Now, somebody comes up and makes contact with it, provides that path. Again, that's where people get hurt. Okay, so very important. So we want to look at an illustration that kind of lays this out. So let's look at this illustration. Well, kind of not an illustration, more or less a chart on what you can remember here. What the takeaways? So if you happen to have a generator that's a floating neutral, and that's what's marked on your generator, then it will not clear a line to ground fault, because there isn't any path to get it back to the source, right? It also will not function for a ground fault that would clear a GFCI device. Since there isn't a path for current to return to the generator windings, on a floating neutral generator, it will not function properly. Now, neutral bonded generators, okay, the one that has that jumper, first one we talked about. The overcurrent device will operate as normal, allows that ground fault, allows that current to skyrocket at the point of the fault, allows that to get back to the source and complete that path. Now that overcurrent device will function quickly as it's supposed to. And then the GFCI, because there is a return path on a ground fault condition, it will allow that GFCI to function adequately as well. Okay. So these are all good things. So that's why you want to have a neutral bonded system, okay? Neutral bonded generator. All right, so let's kind of look at the path of what happens when you have a generator that does not have the bonding. Okay, so here's a generator, portable generator. It's unbonded. So this is the floating neutral or type of generator. So we don't have any connection from here, okay, over to the frame. Okay, we don't have it. So here's our GFCI receptacle. Here's our load that's going to plug into it right here, just plugging in. And now we have this ground fault. All right, we have this ground fault. So current is going to be passing through here, stops right here onto the frame, right? You're still going to have your load that's going to pass through the load. The GFCI is not going to function. The overcurrent device here is not going to function. In fact, this frame could sit energized, right? All of that, okay? That's a problem. The moment that you throw in this jumper and this becomes a bonded generator, now that fault current gets back to the source, skyrockets at the fault, and that's what clears the overcurrent protective device quickly, okay? That type of thing. Also, because you're looking for the return path outside of the GFCI, if it gets back here and stops right here, it's not getting here to create that imbalance. So the GFCI will not pick up on that and will not function. Okay? So that becomes a problem as well. Now, let's read a little further. It says the designation as a separately derived system. Okay, so that's what a portable generator is with the bonding jumper on it. Okay, so we're having it from the neutral point over to the frame. That would be standalone. That's a separately derived system. Okay, it requires a neutral and equipment grounding conductor to be bonded to the frame of the generator. We all agree. And the transfer equipment to switch all conductors That is so important. So if I use a generator, portable generator, and I just go buy a bonded generator, that's a separately derived system, and I go install it at my house, okay? Now what I've got is what? I've got a transfer switch. If I'm not going to switch all of the conductors, even the neutral, then the problem is I've got a separately derived system that I'm being placed on a system, and I've got a problem here, okay? The problem is if I don't switch the neutral through transfer equipment, now I've got parallel paths, right? So this designation and switching arrangement where you do switch the neutral on a separately derived system like that generator with that bond in it, okay, then it prevents parallel current, right? It prevents this arrangement. And what it does is it prevents neutral from being in parallel with the equipment grounding conductor, since it is required to be switched in the transfer equipment. Why is this so important? Well, a lot of times when you order, generators, and let's say whole house generators, is kind of talking about separately derived systems. When you order a residential, not talking portable now, but we'd say you order a residential generator, whether it's Generac, Kohler, whatever the manufacturer may be, you have to look at the transfer equipment because it could come with that bonding jumper in it, system bonding jumper already installed. It could come with that, but yet the transfer equipment is not switching the neutral. Well, that's a problem because it allows circulating currents to go back through the generator from the service back through, and since at the generator, the neutral is connected to the frame and also the equipment ground, it allows for parallel paths of this neutral current to travel, right? And so that means that metal parts can become energized, right? It's part of that neutral path. So that's an unsafe condition. So you have to be careful. So if you did have that, then it is separately derived. Now you have to look at a transfer switch and you need to make sure you're switching the neutral so that you break that path. When the service is being running, you're breaking it. All of the circuit conductors, not just the hots, but even the neutral are being broken in that scenario. And so think of it this way. If you're not breaking it at the generator, then you have to break it at the transfer switch. Otherwise, you get these circulating currents. So these parallel paths of neutral current. It creates problems, circulating currents and all these kind of issues. So the transfer switch is critically important for that aspect, right? Okay. I'm going to make sure that we at least hammer that home, that switching of the neutral is very important, determining whether or not your generator is separately derived or not, okay? It plays a critical role in that. Now let's talk a little bit more. It says the neutral or frame of the portable generator is not required to be connected to grounding electrode, and we talked about this, as long as all power loads are supplied from receptacles mounted on the generator, okay? So the neutral or frame of a portable generator is not required to be connected to any electrode. We saw that. That was the very first thing that we looked at. Not required. If all the load is supplied through receptacles that are mounted on the generator, or the actual equipment associated with that generator is mounted on that actual generator, okay? Now, because the neutral and equipment grounding conductor are connected to the frame, as required in 250.34c, overcurrent protection and GFCI protection on the generator will function correctly, okay? So this is a generator where you have the bonding jumper in it. Everything's bonded, okay? The equipment ground terminals for the receptacle is intimate with the metal framing of the generator, which is intimate with the neutral point on the windings of the generator. If that's all done, and all the receptacles supplying the loads are cord and plug on the generator, or the equipment itself that's supplied by the generator is on the generator, then I do not have to have any electrodes. We've already established that, right? Okay. So we're going to look at another figure real quick. And this is when we're talking about things like transfer switches for generators, portable generators. Okay. All right. Figure 2-72. That's this one down here. It says shows the type of transfer equipment that is often installed to provide the supply of a portion of a premise wiring system by a flexible cord from a portable or vehicle-mounted generator. Okay, so this is the inlet. Okay, and this is a transfer switch that would be utilized. One of them that would be utilized. It says the flanged inlet receptacle provided for the flexible cord connection. Circuits to be supplied have been connected through the transfer equipment and are selected by rocker type switches. So this is what we see right here. So here's the inlet, and it would go from here over to the generator, right? And these are your rocker switches that allow you to turn on the different circuits that are supplied through this small looks like 6-circuit transfer switch, okay? All right, so in looking at this transfer switch, and you can look in right here, here's your service equipment, okay? And right here, you've got your service equipment, you've got your main bonding jumper, everything's installed, and here's your electrode. So this is your service. And here's the receptacle right here. This piece right here is the actual depicting this receptacle, right? So here's what happens. Now, if you go by a portable generator, okay, and in this case, this is one that is bonded, right? So this is bonded right here. So let me kind of blow this up if I can. Oops, that's not what I want. Let's see here. Trying to find out where I zoom in on this here. Let's see. There we go. That's about the best I can zoom in. All right, so here's what you got. Because this is connected together right here, right, you have to switch the neutral in this transfer equipment, right? Well, this is a problem because they don't switch the neutral. And then this piece of equipment, if you look inside of it, you see right here, the transfer equipment, and this is the inside of one of these back here, by the way. This is opened up, turned open. You'll notice that the neutral is not switched to prevent parallel path for neutral current. So if you're using a portable generator or a vehicle-mounted generator, that does have the bonding taking place in it, which is what you would use if it was a standalone, by the way. You're going to have to select a transfer equipment that does what? That actually switches and shuts off the neutral. Because if you don't do that, then it's going to create parallel paths for neutral current. And then, of course, all these bonded connections are now going to be energized with neutral current. So critical to not just buy components, put them in, buy a generator, and not know what your application is for. So typically a floating neutral generator would be what you would use on a dwelling, whereas a bonded type generator is what we would want to use as a standalone application, okay? And now I'm not going to get into modifying generators. We'll leave that for you to search out and find for yourself. I'm not going to get into that liability trying to explain that here. But okay, just be careful and realize that if you're going to use a generator that has the neutral connected to the frame, which is what you would use in a standalone, that if you're going to use it in this scenario, you need to what? You need to switch the neutral. And the sad thing is, when you're buying transfer equipment, it doesn't necessarily always come with the generator. So you got to be careful what you buy. You got to know what you're buying. And again, you can create a serious issue if you don't know what you're buying, okay? All right, now, the drawing in the middle of figure 2-72 shows a typical circuit where the portable or vehicle-mounted generator is connected to the premise wiring through this transfer equipment, right? That's very typical. This right here is very common. People buy them every day of the week as transfer equipment, right? Because the equipment grounding conductor and the neutral are connected together at the service and at the generator, neutral current will be in parallel with the equipment grounding conductor. Okay? So the lower picture shows the inside of the transfer equipment shown in the upper photo. As can be seen, the neutral connection is not switched. That is a serious hazard. All right. That means it's neutral current, even in this service, when it's back to a service, that it can actually send neutral current back through, over through the winding, back through here, and then back on the equipment ground, creates a loop. Okay. So it creates a very unsafe condition. All right. So if you're going to break it here at the generator, right? And if you do it here, then that's where typically you don't need to break it. You can use a solid bus type transfer equipment. But if you're going to connect it over here, then you're going to have to, and this creates a separately derived system here, then you need to switch the neutral. Okay. You need to break that cycle of paralleling the neutral like that and creating that circulating current. It's all going to hinge mainly on your transfer equipment, okay? So, doesn't mean I can't use a generator like this, but I have to make sure that my transfer equipment accommodates that, okay? All right, folks, let's bring it back to me. So the moral of the story here is, if I'm going to use a generator for a construction site, camping, as a standalone, separately derived system, I don't need grounding electrodes for it as long as I meet those conditions. Either the equipment or the receptacles are mounted on the generator and it's cord and plug type of application, then I don't need grounding electrodes, okay? I don't want to use a floating neutral generator in a standalone application, okay? If I do use a portable generator to supply power to a dwelling, then I want to make sure that if it is a bonded generator, that I have a transfer switch that switches a neutral. If I'm using a floating neutral generator, then it's okay for me to have a transfer switch that is solidly connected, not switching the neutral. But again, you only want to use the floating ones on a premise application, because we just saw what happens if you use it as a standalone. The GFCIs won't function, and the overcurrent device likely won't function, so that becomes a safety hazard as well. Moral of the story, think about the generators you purchase and the application that you're using them for. If you are truly going to use it just for portable needs, right, then do me a favor. If that's the application you're going to be using it for, get a generator that has a bonded neutral and use it for those portable applications. All right? Okay, folks. We'll go in depth in other applications from generators, interlocks, and all this kind of stuff, and the feasibility of those in a later episode. Till next time, folks, stay safe. God bless.